What's the derivative of x to the x? Well, it's not a polynomial, and it's not an exponential either. It's something more in between. So we're going to have to be a little bit creative. Let's start by first writing y equals x to the x. Now, whenever we have a function to a function, we can make this a little bit simpler by taking the natural log of both sides. Now the reason we do this is this function up here now, in this case is just x, but since there's a natural log, we can just move this function to the front like this. So we're going to get x ln x. And now from here, there's two ways we can find the derivative. Method 1. Implicit differentiation. I'm going to take the derivative d dx of both sides of the equation. And from that, here the derivative of ln y is just 1 over y. But since we're taking the derivative with respect to x, we got to do a chain rule. So the derivative of y with respect to x is just dy dx. And here we have a product rule. The derivative of the first is 1, so we have 1 times ln x plus x times the derivative of ln x, which is just 1 over x. And if we simplify this, I'll move the y to the other side. We'll get dy dx is equal to y times ln x plus 1. And what is y? Well, as we wrote earlier, y is just x to the x. So we get x to the x times ln x plus 1. Let's now raise both sides to the power of e. Of e and e. This tells us that e to the ln y is just y. And we'll have e to the x ln x. So this is just y. Now we can take the derivative of both sides and see what we get. So here we'll just get dy dx. And here we're going to have a product rule. So the outer function is e to the power of something. E to the power of something is just e to the power of that same thing. X ln x. And now we're going to have to take the derivative of x ln x. Oops. Which, as we did earlier, is just 1 times ln x plus x times 1 over x. And as we rewrote earlier, e to the ln x, that's the same thing as y, and y is the same thing as x to the x. So we can just write this as x to the x times ln x plus 1.